Your E value was, does anybody remember what number he said? 2.718 is as far as I'm going. We're not doing all 30 digits. And whose number is this? I used to say Euler, and then Miss Nelson, shout out Miss Nelson, corrected me. It is Euler's number. So you don't have to have that memorized or anything like that. But that's going to be used when we're compounding continuously, which we'll talk about in just a minute. The compounding interest formula is A equals P times 1 over R to the N raised to the NT. And right below it tells you what each thing means. P is your A, let's do A first. A is the amount that you have in your account. P is the principal, your present value. How much is currently sitting in the account? A is how much is in the account after you do this, after 2 years. R is your rate, your annual interest rate. N is the number of times you compound per year. And T is the number of years. Now, that's if you compound annually, semi-annually, monthly, or weekly or daily. What if you continuously compound? Everybody highlight, underline, do something, box it, the word continuous. If you continuously compound, here is your formula. A equals P to the RT. Or as I like to say, PERT. If you can memorize PERT, you have half of the formulas memorized today. P is, again, still principal. E is the number, 2.718, but we would just put E in the calculator. And then R is still rate, and T is still time. So, how do we use this? What does this mean? Well, if Christy invests $300 into an account with a 6% interest rate, making no other deposits or withdrawals, what will Christy's account be after 20 years if the interest is compounded semi-annually? So what do I know based on this word problem I've been given? How much does she have in her account? 300. What letter is that? 300 is the letter P. What about 6%? 6% is my R. However, R is not 6%. Whenever you have a percent, how do you plug that into the formula? Do y'all remember to move the decimal over twice? So R is 0.06. What is this 20? That's my T. That's my years. And so these down here, these semi-annually, monthly, and daily, these are my ends. This is how many times I'm going to compound per year. If it's semi-annually, how many times do you compound? 2. What about monthly? How many times would you compound for monthly? And daily, how many times per year would you compound? 365. Louder? Oh. Okay, so how do we do this then? We're just going to plug in to my first formula right here. So I'm going to say A equals, my P is 300 times 1 plus the rate is 0.06 over 2 raised to the 2 times 20. Your exponent is how many times you would, compound throughout the whole time. So if it's 20 years and you're compounding semi-annually, that's 40 times total. That's what that exponent is. And then, what am I going to do? Just plug it into Desmos. Now, are you getting Desmos on your test? Absolutely not. No, you're not getting Desmos for this test. You're getting a baby calculator. So, am I going to expect you to do this in a baby calculator? Y'all think I'm that wild? Noted. Yes. Louder? How does leap year work? So if you did it daily, it would be 364. But with leap year, it still will be E. Like if it's doing continuously, it's still going to be E. But yep. Okay, what am I doing right now? 20, right? There we go. No, not 364, 366. You just compound an extra day here. But that shouldn't change the continuous compounding. All right, so how much money will you have in your bank account after 20 years? $978.61. So you're telling me if you put in $300 after 20 years, you'll have $900? That's not a lot, right? And I have some really sad news for you. Bank accounts, actual interest rates are more like 0.06%. Bank accounts are really rude. If you, banks are, I think my interest rate for my bank is something like that, 0.03 or 0.3 or something. It's really, really sad. It's not even a whole number. All right, what about monthly? Can you, so if I'm not giving you a Desmos calculator, how do I expect you to do this? I don't. I only expect you to set up the equation. So can you please set up these equations? There's no way I would have you do it. Say it. There is not Desmos. You just set it up. You're just giving me the equations here. Yeah, let me finish the math and then I'll let you go. Is that okay? Please look up and make sure your equations match my equations. I know y'all do not have Desmos open, so if you can also look down the answers. What about the jump from semi-annually to monthly? It's a pretty nice increase for each, right? What about from monthly to daily? That wasn't like a too much increase because you're, how does continuously change? How many times is this going to compound per year? It's actually going to compound infinitely many times, but you are going to use E for that. So this one's going to be different because for this, we're going to say A equals 300 times E to the RT. So this time, instead of doing your number of compounding as the exponent, it's going to be your rate. This is PERT. And when I put this in the calculator, what do we get? Is it that much more than compounding daily? Like 10 cents more. Right? So, where would we use this in the real world? Why is this relevant? I just told you bank accounts, if you have a savings account, most savings account, I guess we could look it up, but most saving accounts earn interest very little. Wow, I spelled that wrong. Interest rate. Oh, there we go. Spell interest wrong. I still spell interest wrong. Okay, savings account interest rate. That's a high yield savings account. A high yield savings account is a lot more than a regular saving. Look, 0.01%.
Oh, wow.
Yeah. And banks, you know, the rich get richer. Banks, the more money you have in the bank, the higher they'll make your interest rate. So as you end up saving more, they're like, oh, look, you have $20,000 in your savings account. I'll give you 0.06% interest. Oh, look, you have $50,000 in your, I'll give you 0.09% interest. And they give you more as you put more in there because, right, they want your money. So savings accounts aren't always the best way to go if you want to save. High yield savings accounts are pretty good. But there is also something called a Roth IRA. Have y'all ever heard of that? So if you haven't, let's go down the list of, have y'all heard of Social Security? Yes. Okay, right now there's like a big to-do politically about Social Security. We're not going to get into that. But did you know teachers do not pay into Social Security? I pay into, all of us pay into something called Teacher Retirement Fund. So we have a different pension saved than Social Security. And have y'all heard of a 401k? Okay, a 401k is another way to save for retirement. 401ks have higher interest rates, which is good. However, they're also locked in. You get penalized if you take from them by a certain age and different things like that. Most people can't touch their 401k till they're well into their 60s or 50s. Yeah. So it's locked in for so many years, and that's how come you're getting the high interest rate. And then for teachers, we don't have Social Security, so we can't have a 401k. So we have something called a 403b. And also, a lot of jobs, depending on your job, they'll match whatever you put into your 401k. So like, let's say you put in so much a month, they'll be like, oh, you put in 2% a month, we'll match it. Or we'll match so much percent. Not teachers. But we also have something called a Roth IRA. And anybody can have a Roth IRA. It's not tied to your retirement and what you put in there. So for a Roth IRA, I want to show you what a Roth IRA calculator looks like. It does the calculations for you, but this is what it is, and this is how you want to kind of, if you can always obviously Google it, but looking at this equation, that is what this is doing. So for a Roth IRA calculator, let's say you start at $0 and you are 18 years old and you want to start saving money for your retirement, and you're 18 years old. So let's say in 1 year you contribute $1,000 annually, and you want to retire at 60, right? How much money will you have when you're 60 years old? You'll have $230,000 saved for retirement. But let's say you're 18 and you just don't make those decisions. So you graduate college at 22. And annually, you still want to do $1,000? You're going to have $172,000. Why did that go down? Because you started later, right? Well, I started my Roth IRA at 22 because I didn't know anything at 18. And I was big balling back then, not really, but I had all this money that I had never had before. So I decided to contribute $5,000 annually. What? Is that a lot? What is that laughing about? At retirement, I'll have $8,000. Nope. At 50 years old, I'll have $862,000 saved for my retirement. Now, another teacher here is super big balling, and she wants to max it out because Roth IRA, there is a max you can contribute each year. She's going to max it out, and the max is $7,000. Watch what happens if I try to contribute $8,000. It tells you can't. You can only contribute $7,000 because the interest rate's so good, or better than others. Big ballin' teacher's going to have over $1 million at retirement. Now, another one of my coworkers, she's new, and she's 25. She is just starting her IRA, and she's like, ooh, I'm starting my IRA. That's how much it went down. It went down $300,000 almost. So depending on the later you start, what happens? And then I have another coworker who is past 30, but she did not start until 30, and she's only contributing $4,000 each, and she's only going to have $377,000 at the end of retirement. So these things matter. Now, I can go in and change how much I contribute at any point. So for instance, when I turned 18 and I was big balling, I put it in. And then when I turned 25, I was even bigger balling, and I was like, oh, let me put in more. And then I had kids, and I was like, yo, take some out. So you can go in and you can change these things. This isn't going to be exactly what it is. But it's cool to see, and it's nice to see, you know, you set up yourself for retirement. It's not the end-all be-all. And somebody last period was like, well, what if I'm dead? You might die before 50. You put a beneficiary. It goes to whoever you choose. But these are things that you want to start looking at. You are going to hopefully go to college, or even if you don't go to college, you are going to get a job that is going to make more money at some point. I went from making tutoring money, which is not a lot, to taking home a paycheck that was over $1,000 every 2 weeks, and it was like, whoa, yeah, that's nice. Save it. You don't need it. Save some of it. All right? But don't just save it in savings. Save some of it in a little bit of different pockets. So that's what this calculator is kind of here to show you, different things. Also, you can change this around, and you can see what happens based on the interest rates and different things like that. All right, so that is a Roth IRA, and that is how this right here applies to savings. And a Roth IRA compounds continuously because they want the max amount that you can get. Do I have any questions? Yes. Say it louder. Oh, banks want your money. Because banks also give out money that people don't have. Think about it. Credit cards, they're giving out that money, so they're trying to, it's all a balancing game. Yeah. Yep. They want you to put as much money into their bank. Okay, because that means you're also going to take money. Yep. All right, that is compounding. Now, let me talk about real quick. This is all about money. So these formulas right here have to do with money, bank accounts, savings accounts specifically. All right? This does not have to do with credit cards or anything like that. This is all savings accounts. Now, if you turn over, the back has to do with quantitatives. So you're going to see this is a lot about population, different things like that. This is when it still involves growth and decay, but it's not necessarily money. All right? So for this right here, for exponential growth and decay, we are going to have, and these formulas are very similar. They just use different things because we're not going to use P for principal because it's not principal anymore. It's your initial value. So instead of using a P, they're going to use an N naught. And that's your initial quantity, your initial value. You're going to have an exponential rate. They're still going to use R, but sometimes they use K, and I have no idea why. And then N is your A. It's the amount after however much time, which is still T. So we have growth and decay, and this is your formula. This time you are not going to have to divide because you're not going to compound or anything like that. So it's just 1 plus your rate times the time. If you are growth, what's your rate going to be? If it's growth, you're going to have if it's growth, your rate is going to be more than 0, which is positive. And if it's decay, your growth is going to be, or your rate is going to be negative. If you have continuous growth or decay, it's exactly like the last formula. This is still PERT. Just again, are we using principal? No. And I don't know why they use K instead of R. I don't understand that much, but same process. Your rate will be positive if it's growth. Your rate will be negative if it's decay. So, Mexico, they have a population of approximately 128 million. If Mexico's population continues to grow at the described rate, predict the population of Mexico in 10 years. What do I know? I know the not. I know the initial value is 28 million. The time is 10 years. And then I know the rate, it tells me on A, what's my rate here? What would this rate be? It's going to be a growth because it's positive. And how much is it going to grow by? I'm going to go 0.0142. And so then I am going to say n equals, and yes, you have to write out 28 million because that's what you would type in the calculator. Really, the 6 zeros is less than million. And I'm going to do 1 plus 0.0142 raised to the 10. And that is what I'm going to expect you to do on your test. Louder. I am not giving you the formula. And then if I put this in the calculator, let's do 128, 123, 123, 1 plus 0.0142. I get 147,382,538 people. When they do the census, do y'all know about the census? The census where they calculate the population of all the cities and things like that. Do you know how often they do the census? Every 10 years. So they do that every 10 years. Obviously the number is going to grow a lot between the 10 years. But I'm sure there are also some, what is the word? Unofficial ways to calculate the population annually, right? All right, I would like you to do the one that is continuously. You got it? Good. She was, yeah. So if you compound continuously, is this your equation you got? What questions do I have? Any questions? I want you to do the last two. Go. Did you get this for your first equation?
Oh, it's declining.
It's declining. Be careful. This declining means decay. Which also means you need to make sure your second equation has what? Negative in the exponent. Also, if you get an answer, I know on your test, but like on a homework or something, if you get an answer and if it was more than that number, wouldn't you say, hey, something's wrong with that because it's declining. So just be aware of that. And then I'm going to put these in Desmos real quick for you. Is that right? Okay, so if you're going to round up right here. Yep. Because we're talking about people, so we don't want decimals when we're talking about people, right? No, 9-3.
Okay. Well, but here have 6, 9, 4 people.
What?
I can deliver on the phone. Let's say they do it first time. I can deliver it.
Right.
Oh, nope, that's wrong.
20. 21.
It's by 290.
What's the other one then?
What questions do I have? What? That's the one I go to. I'm going this weekend. Probably today or tomorrow.
Oh, I don't work those.
Oh, yeah.
You should go Monday.
No.
Go Monday, Thursday.
All right. If you can please put this to the side, I want you to get out the other paper that you picked up. The review. So here's what I'm going to say about that. You're not going to be rounding because you're not going to have to do that. You're only plugging in. Now, if it is growth, you are going to round down. If it's decay, you are going to round up. Yeah, if it's growth, you're going to round down. If it's decay, you're going to round up. But again, y'all aren't rounding on the test, so I'm not like super worried about it. What? Are you going to have what? Louder? No. So a couple things I want to do real quick. The calendar, just to remind everybody in here, we are reviewing on Monday. I'm going to go over this review. I'm going to give you back quiz A, and we're going to review what we just did. Tuesday, you have a test over this. Kind of fast. Because of that, I need you to look at this review that I gave you. Why does it say logs? Because I want to remind you, this is one whole unit. I broke it up into 2 tests. So if you can please write right here, I need you to keep this until at least April 4th. Yeah, because that is your assessment over this. Your test is that Monday. So April 4th is, don't throw this away. I want you to write it up top so when you start cleaning out your backpacks, because y'all do that. I threw it away. No, we wrote April 4th on it. Now, this is both test information. This is actually a really good review for your assessment on April 4th. However, I'm going to use it as the test review as well. So, worksheet 1 is a test review, but numbers 1, please circle or highlight. Number 2, you're graphing 1 and 2. You can simplify 5, 6, 7, 8, and 9. Circle those, please. And that's all you can do from the top. Everybody have those circled and written down? On the bottom, the only ones you can do are 24, 28, and 30. 27 you cannot because they do not have the same base. We're learning that next test. Same thing with 33. They have different bases, so we can't do that. It is, yeah, basically everything we're doing is algebra 2. All right, so what I'm asking of you is I would like you to have those 10 problems done when you walk in on Monday so that you can ask me questions and I can go over them. They're not for a grade. If you don't do them, I'm just not going to give you the review that I think you deserve. So to get a good review, I would like you to do those. All right, last 10 minutes of